In the previous two videos, I've introduced you to the idea of torque. The torque delivered to an object by a force describes the effectiveness of the force in changing the object's rotational motion. Another way to put it is that the torque is the twist that a force gives to an object that can rotate. I also introduced you to this formula here, which provides one way of calculating the torque. In this video, I'm going to introduce you to a second formula. To introduce you to this new formula for calculating the torque, let's start by saying that we have an object that can rotate here, and I have marked the center of rotation over here. Now let's say that a force comes in to act on the object. And I would like to calculate the torque that this force delivers to this object with respect to the center of rotation over here. The first thing I do is draw an infinite line that passes through the force vector. Once I've drawn the infinite line that passes through the force vector, I then go to the center of rotation and drop a perpendicular to that infinite line of force. In other words, I start at the center of rotation and then draw a segment which meets the line of force in a right angle. The length of this segment is known as the moment arm. The moment arm is denoted by R, and then with a subscript, which is the symbol for perpendicular. Now, before we go to the formula for torque, we want to introduce a sign convention because we're going to use the sign convention plus or minus to distinguish between clockwise torques and counterclockwise torques. So I'm just going to come into the figure and show an arrow looking counterclockwise with a little plus sign. This will indicate that we're taking counterclockwise torques to be the positive ones. Anyways, proceeding now to our new formula for torque. This new formula for torque has it that torque is equal to plus or minus, to distinguish between counterclockwise and clockwise torques, multiplied by the moment arm, multiplied by the magnitude of the force vector. And that's it. This is our new formula for torque. Now I'm going to show you a very quick example problem to illustrate how we would use this new formula for torque. What we have here is a situation where a table is being dragged along the floor towards the right, and whoever is dragging that table is using that 50 Newton force applied to the top of the table, pulling to the right. We're going to say that our center of rotation is at the bottom of the left leg of the table where it contacts the floor. And we're also going to say that the vertical distance from the center of rotation down here at the floor up to where we have the actual surface of the table is 0.8 meters. So for this situation, what is the torque that the 50 Newton force exerts on the table with respect to the center of rotation down here? As usual, before we can calculate a torque, we need to define our positive direction for rotation. So I'm just going to go into the figure, draw an arrow hooking in a counterclockwise sense with a little plus sign. That says that counterclockwise is our positive direction for rotation. Then I'm going to just start by copying this new formula for torque. Torque equals plus or minus moment arm times force. Okay, now first of all, is the torque delivered by this force clockwise or counterclockwise? To illustrate that, let's just say that this rectangular piece of paper here is the table, and I'm going to just hold down that bottom left corner. And since we have put the center of rotation at the bottom of the left leg of the table here, what I'm going to do is just hold down that lower left corner of the piece of paper to force the piece of paper to rotate around this point. And then, similar to that force coming in, grabbing onto this edge and pulling to the right, I'm just going to come to this corner here and pull to the right. And can you see that when I pull to the right, then the, quote, table rotates clockwise around the center of rotation here. So that tells us that this force actually delivers a clockwise torque with respect to the center of rotation over here. So this would actually be a negative torque according to our sign convention. So negative torque Now to find the moment arm, we draw an infinite line through the force vector. Then, as I showed you over here, the moment arm is the perpendicular distance from the center of rotation up to the line of force. So I'm going to come in here and draw the perpendicular distance from the center of rotation up to the line of the force. This would be our moment arm, denoted R perp. And you can see from over here that the moment arm would just be 0.80 meters. So for the moment arm, I'm going to plug in 0.80 meters. The magnitude of the force is 50 newtons. We have then that the torque that this force delivers to the table with respect to the center of rotation here is minus, and do the multiplication to get 40 newtons times meters. So now I've shown you two different formulas we can use to calculate torque. And in the next video, I'm going to introduce you to one more concept that we need to understand before we can really dive into rotational dynamics.